Hello, welcome to SM Call. Today we are going to solve the day 10 of July LeetCode challenge. So today problem statement is flatten the multi-level doubly linked list. So if you read the problem statement, it's saying that you will be given one multi-level double linked list. So at first you need to understand what is the multi-level double linked list, right? So in double linked list or double linked list we have two pointer, right? One is next counter, one is previous pointer. But in this case you will have another extra pointer called child pointer, right? So if you check the diagram, you can understand what is multi-level linked list look like. So let's try with this small example first, then we can check the larger one. So if you check that this will be your input like 1 2 3 null. So how you can identify that what is the child from here? So if you start from 1, then you find 2, then 2 is the next node. Then if you find null, means the first linked list end here or first level end here. Then whatever you will be after that will be child of the first. So then after null immediately it is 3, right? So here 3 is the child, 3 is the child of 1, right? So it will look like this 1 2 3, and then you need to make flat this level, right? So how can you flat this level? So you need to start from the head, then you need to check that if you have any child, then you need to consider that, right? 1 then 3. Again you need to go iterate to the child till you find the tail of the child, right? So in this case the next node is a null itself, so that is the tail of the child. Whenever you will find the tail of the child, you will need to go back and complete the rest of the iteration of the main linked list, right? So again, so I will start from 1, then I will see that 1 has one child, then I will go to the child and I will iterate through the child till I find the tail node. In this case the first 3 is itself a tail node. Then I will again go back and I will start continue from 2 and null. So output will be 1 3 2 null, right? Something like that. So similarly this example is also same. So it's a larger one, nothing like that. So suppose you have this input, right? Again you will start the first linked list look like 1 2 3 4 5 6 9, then null, right? This first null means this linked list end here itself. Then you need to consider from the next. So null 7 8 9 10 null, right? So this will be your second linked list. So if you put the mapping, so 1 means 1 below 1 it's null, means 1 don't have any child. Similarly 2, similarly 3. So in this case you find that 7 is below 7, 7 is below 3, right? So that means 7 is the child of 3. Similarly, if you check it that 8, so 11 should be the child of 8, right? So it will look like this. So if you break this whole single array, you will get 3 array or 3 level, right? And you need to map the index of each of the item. Whenever you will find any non-null value, that will be the child of the main index, right? So if you think this is my first level and here the 2 value is null, then again I found a non-null value 7, then 7 is the child of 3, and we will go. Even similarly, if you find that 11 will be the child of 8, and we will go. So if you check this example, right? So so if you check, so what will be the output? So you need to start from the head node, then you go, and in this case head node don't have any children, so I will move forward my counter and I will find that I found 2, but it has child, right? So I will come down and I will iterate to the child, and again I will find again that 8 has a child, right? 11, and again I will come down and I will iterate till end, right? In this case we don't have any more child, so I will stop here. Whenever I found the tail node of the child, I will go back and again start from 9, right? 9 10 null. Again I found my tail node, again I will go back and iterate the rest of the 4 5 6. That will be the output, right? So this is the logic. So there are multiple ways to solve it. You can use recursion or you can use iterative way. So for today I am going to use the iterative way and I am going to solve it using Java only. So let's begin. So what should we do? At first I need to check that my head is null or not, right? If my head is equal to null, means if my input is null, then I can safely return null. We don't need to perform anything. So that will be my first step. Again, and here you can see that we need to return the head, right? So we cannot modify the actual pointer. So probably I will take one copy of the head. So let me name it as node, then current, something like that, and I will take a copy of the head, so that I can iterate through this current and I can return this head, right? Whenever I am done, I will going to return head. So I will move my pointer using this current, not using the actual head one, because I need to return the head, right? So if I move through that head, then I will lose my count. my head pointer, so that I make a copy and put that value in a current, put that reference, right? So let's start. Then what I will check, I will so means if you check the diagram, I am here, right? This is my current node right now, so I need to check that my current value is none. I need to iterate till here, right? So at first what I will do, I will write like current not equals to null. If it is null, then we are done. We will stop and return head, right? If current not equal to null, then what I am going to check, I am going to check. So at first whenever I am here, I will check if I have any child. If I have child, then I need to go down to the level, right? So I need to check that. So I need to check that cur dot child equals to null. If it is equals to null, then we can move forward, right? Cur equal to cur dot next. This is a normal scenario when we will not have any child, right? Else if we found any child, then I need to go down to that level, right? So so suppose I am here right now 2, right? And I found, yeah, I have one child. So here probably 3. So I have one child and my child is 7. So I need to go down level, right? I need to down my level. So I need to store my next location, right? Else I will forget where was my next location. So for that I am going to take another node called next, and I am going to store the next value so that I can link it, right? So yeah, and again I am going to take another node called child, so that I also know that what will be my child value. So it will be cut.child, right? Yeah, now what are we going to do? I will change the counter, right? So my next my current dot next value will be my child, right? So what I am I am here and I found I have child, then I will set, I will make 3 dot next equal to 7. So I will go through like my linked list will be starting flatten, right? So after 3 I am going to traverse this 7, 8, 9, 10, so that it will be flat, right? So it will be like this current dot next equal to child and child. So since the doubly linked list, you need to do the linking in both sides, right? For previous also. So child dot prev equals to cur, right? So done. Now what I need to do, I need to iterate through these children, right? And to check the tail node. So I will look right like this, while child dot next not equals to null, I will move through, right? So child equal to child dot next, something like this, and yeah. So whenever I find my child dot next, means I am here right now I am here, right? So I found that my next node is null, so I need to go back, all right? Go back and I need to link it with the next node, right? So let's do that also. So it should be child dot next equals to my next node, right? I already took that next, and I need to check one thing. If next is, I need to do the previous linking also. If next not equals to null, then I am going to make next dot preview equals to child. Yeah, that's pretty much. Let's run the code and check whether it's accepted or not. Is it throwing any error? Let's check that also. So it's throwing time limit exception. Let me check the go through the code and fix it also. I missed one thing here. So I need to do another thing right here. So for current, I need to set the child as null, right? Else it will go to infinite loop. So yeah, that's pretty much. Let's try now. I think it will work now. Yeah, it's now giving me same answer probably. Yeah, let's submit our solution also and check whether it's accepted or not. Yeah, it's accepted. Let's check the time complexity also. Yeah, you can see it's with 100% Java submission. I think that's good. And so you understand the logic, right? So we started from the root node, then I check that I have any child, then I go through that child. So and if I found the tail node, I again then go back and continue my iteration, right? So I need to do this line, right? What I missed during coding this, you need to set the child null, right? Else it will go infinite loop. You are not flattening actually. Yeah, that's pretty much for this video. If you like this video, please subscribe to our channel and share it with your friends. Thanks for watching. Bye bye.